Hi, I'm Patrick Reagan. Welcome to TCP/IP Part 4 Internet Protocol Types. This video is a continuation of the last two videos where we discussed the common protocols found in the TCP/IP protocol suite, and this will complete the CompTIA Network Plus 1.4 objective. This video covers ICMP, GRE, and IPSec. It also covers traffic types including Unicast, Multicast, Anycast, and Broadcast. Generic Routing Encapsulation, or GRE, is a tunneling protocol developed by Cisco that can encapsulate a wide variety of network layer protocols inside virtual point-to-point connections. GRE is used to create a private point-to-point connection across a public network such as the Internet. It encapsulates traffic inside of the Internet protocol packet where two endpoints appear to be directly connected to each other. Basically, it's a tunnel between two endpoints with no built-in encryption. It's often used in conjunction with IPSec to create secure VPNs. GR's ability to transport multicast traffic and support different protocols make it a valuable tool in modern networking. GR will add an additional 24 bytes overhead, but you can use jumbo frames to ensure the GRE overhead does not affect payload. A jumbo frame is an Ethernet frame with a payload larger than the standard maximum transmission unit, or MTU, of 1,500 bytes, which usually leads in increased efficiency and higher performance. Jumbo frames can typically carry up to 9,000 bytes of payload, although the exact maximum size can vary depending on the network hardware and configuration. A virtual private network, or VPN, is a secure encrypted connection that extends a private network over a public network, such as the Internet. It allows users to send and receive data as if their devices were directly connected to a private network, or to have a direct connection to a server just as if they were connected locally. If you connect to a server directly, you can manage the server, or you can use it as a jump box to other servers or devices. A tunnel refers to the secure encrypted pathway created between your device and a VPN server, ensuring your data travels privately and securely across the Internet. Think of it as a private protected pipeline where your Internet traffic is shielded from prying eyes and potential interception. Key functions of a VPN include encryption, where VPN encrypts data in transit, preventing third parties from reading or tampering with it. Privacy hides your IP address and online activities from your ISP and other observers. Remote access lets users securely access a private network like a company's internal systems from a remote location. And lastly, bypass censorship or geo-restrictions by allowing access to region-restricted websites and services by masking your IP address. VPN can be deployed with specialized cryptographic hardware or software. A VPN concentrator is a hardware networking device that enables multiple simultaneously VPN connections to a single network. It's essentially a specialized router or firewall that handles many VPN tunnels efficiently. It is often used by organizations to allow remote users to securely access their corporate network. An always-on VPN is a type of VPN connection that is automatically established and maintained, ensuring a constant secure connection to a remote network, which is different from traditional VPNs, which requires users to manually connect and disconnect. The VPN connection is established and maintained automatically, often based on factors like user login or network state changes. Users don't need to manually manage the VPN, making it seamless for remote work and access to corporate resources. The consistent VPN connection ensures that all Internet traffic is encrypted and protected, improving security, and if your computer is on and connected, is available to receive updates, software installs, and configuration changes. There are several types of VPNs categorized by how they are used and the underlying technology they employ. The main types are remote access VPNs, which allows individual users, such as employees, to securely connect to a private network from a remote location, which are often used by employees working remotely or accessing company resources from home or when they're on the road. Site-to-site VPNs establish secure connections between two or more networks, often used to connect different physical locations of a company. Intranet-based VPNs provide secure internal access with the organization's premises, and extranet VPNs enable external clients to access an organization's network securely. Cloud VPNs provide secure connections between users and a cloud-based network, which can be either client cloud VPNs, which allow remote workers to connect to the company's cloud, or network cloud VPNs, which connects different cloud environments. SSL VPNs use SSL or TLS encryption to create secure tunnels over the internet. This often requires no specific client software, making them easier to set up and use. Double VPN is a feature offered by some VPN providers where your internet traffic is routed through two separate VPN servers, which adds an extra layer of privacy and security, making it harder to track your location or activity. Internet Protocol Security, or IPSec, is a framework of protocols and a suite of protocols that ensure secure communications across IP networks, which operates at layer 3 or the network layer. It provides authentication, data integrity, and confidentiality for IP packets, making it a key component of secure virtual private networks or VPNs, but can also be used to secure communications between different types of devices and for securing data transmissions over various networks, even within a local area network. It's also used in software-defined wide area networks, or SD-WANs, for securing remote access. IPSec can be used to do the following: to encrypt application layer data, to provide security for routers sending routing data across the public internet, provide authentication without encryption, like to authenticate that the data originates from a known sender, and to protect network data by setting up circuits using IPSec tunneling in which all data being sent between the two endpoints is encrypted, as with a virtual private network connection. IPSec has two modes. Transport mode, used to secure end-to-end communications such as between a client and a server. The data payload is encrypted, but the header data remains unchanged. Tunnel mode is used for server-to-server, server-to-gateway, or gateway-to-gateway configurations by creating a virtual path that a packet takes from the source computer to a destination computer. When packets are sent along the path, the entire packets are encrypted. It's essentially creating a virtual tunnel that all packets are sent through. IPSec has the following protocols. Encapsulating Security Payload, or ESP, provides data integrity, encryption, authentication, and anti-replay. It also provides authentication for payload. Since it provides encryption or confidentiality and integrity, it is commonly used in IPSec. Authentication Header, or AH, also provides data integrity, authentication, and anti-replay, but does not provide encryption. It does not protect data confidentiality. Since it does not provide encryption or confidentiality, it is rarely used. The anti-replay protection protects against the unauthorized transmission of packets. ESP and AH can be combined to provide authentication, integrity, and anti-replay for the entire packet and confidentiality for the payload. This slide shows you what happens to the original packet that includes the IP header, transport layer header, and data. As you can see, regardless of which mode and protocol you use, most of the content is authenticated, which provides where the packet came from, and its integrity, which will show if the packet has been modified, tampered, or corrupted. However, you have to use ESP or AH ESP if you want the transport header and the data to be encrypted. When ESP is used with tunnel mode, basically the packet is encrypted at the gateway, sent through the tunnel to the other gateway, and decrypted when it gets to the other end. The original packet will be sent on its way to its final destination when it leaves the VPN gateway, just as it was sent locally. For best protection, AH ESP in transport mode provide the best protection from end to end, while AH ESP in tunnel mode provides the best protection from gateway to gateway, but not before or after the gateways. When it establishes the IPSec communications, a security association or SA is established during the first two phases. A security association or SA is a set of agreements between two entities defining how they will communicate securely. It essentially establishes a secure channel by defining security parameters like encryption and authentication algorithms to be used. IPSec SAs are unidirectional, meaning they describe the security parameters for traffic flowing in one direction. Each IPSec peer requires two SAs to establish bidirectional communications, one for sending and one for receiving data. There are two sets of SAs. ICE sets up secure communication channels for negotiation, and IPSec SAs provide the actual data encryption and authentication for the tunnel. Internet Security Association and Key Management Protocol, or ISA-KMP, provides a general structure for managing security associations and key exchange between two peers, including authentication and key generation. It defines the procedures and formats for establishing, negotiating, modifying, and deleting SAs, which are agreements that specify how two devices will communicate securely. ISA-KMP is commonly used in VPNs and other secure communication systems to set up an encrypted channel. Internet Key Exchange, or IKE, is a network security protocol designed to dynamically exchange encryption keys without sending the keys across the network and to build a security association, or SAs, which will be used to establish security communications channels. Key roles of IKE include negotiation, where IKE negotiates security policies and algorithms to be used for the secure connection. Authentication is where IKE establishes mutual authentication between the two peers, ensuring they are who they claim to be. Key exchange is when IKE exchanges cryptographic keys, ensuring secure communication. IPSec primarily uses IKE version 2, which is the preferred choice due to its improvements in speed, security, and efficiency. The keys are generated and shared using the Diffie-Hellman, where both nodes calculate the shared secrets based on the exchanged public keys and their private keys, making it difficult for eavesdroppers to intercept, and the private keys are never transmitted. Essentially, ISA-KMP defines the what of the key exchange process, while IKE defines the how. Note, Microsoft implemented their own version of IKE version 2 that is based on the IPSec IKE version 2. It generates its own VPN tunnel, supports EAP, Active Directory, Smart Card, and Azure AD via extensions, and allows a mobile device to seamlessly transition from one network to another. It supports multiple simultaneously points of attachments, supports always-on VPN, and supports automatic reconnection. Don't get the Microsoft IKE version 2 confused with IPSec IKE version 2. The steps in IPSec include Step 1, Security Association or SA negotiation, IKE Phase 1, which establishes a secure authentication channel between two peers where it creates an IKE SA. IKE uses UDP port 500. Step 2, IPSec SA setup, IKE Phase 2, negotiates parameters to secure the data, including encryption keys, where it creates IPSec SAs, one per direction. It establishes the ESP and/or AH protocol, exchange new keys, and cryptographic settings, and sets up how data will be protected. Step 3, information exchange via the IPSec tunnel based on ESP and/or AH protocols and IPSec mode, transport versus tunnel. Step 4, rekeying and SA expiration, where IPSec SAs expire based on time or data volume, and IKE renegotiates new keys and SAs when needed. Step 5, the IPSec tunnel is terminated. The Internet Control Message Protocol, or ICMP, is a crucial component of the Internet Protocol Suite used for network diagnostics, error reporting, and operational queries. ICMP is primarily used by network devices like routers and firewalls to send error messages and operational information to indicate issues with data transmission. When you use the ping and trace route commands, you're using ICMP packets to assess connectivity, latency, and routing information. Within the TCP/IP protocol suite, packets can be sent to different address types or addressing methods. These addressing methods are sometimes referred to as traffic types. Traffic types is categorized into Unicast, Broadcast, Multicast, and Anycast. Unicast is where one host sends directly to another host, one-to-one. When you connect to a single server or you ping a single server, you're using Unicast. Broadcast is where one host sends information to all nodes at once, one-to-all, similar to a public address system or PA system. Remember, broadcasts don't typically go through routers. Multicast is where one host sends to many hosts simultaneously. One protocol that uses multicasting is Internet Group Management Protocol, or ICMP. Multicasting is used with Internet Protocol television, real-time streaming media, and video conferencing. Anycast is when a host sends to a single IP address in multiple locations, and the network will route to the nearest or most optimum host based on factors such as routing costs, distance, latency, or congestion. You can think of it as a one-to-one of many. Anycast is used in load balancing and high availability systems and to reduce latency and performance globally. Question: what can you use to ensure the GRE overhead does not affect payload when you configure a tunnel between two remote sites? Answer: jumbo frames. Question: what is the secure way to provide site-to-site connectivity? Answer: IPSec. Question: which of the following IP transmission types encrypts all of the transmitted data? Answer: ESP. Question: what protocol does ping use? Answer: ICMP. Question: you're configuring a DNS lookup service that will access the server that is closest to its destination. If it does not respond, it will go to the next closest server. What addressing should you use? Answer: Anycast. Question: what type of addressing is it called when you have one host communicate directly with another host? Answer: Unicast. For more information, refer to these sites. In summary, generic routing encapsulation, or GRE, is a tunneling protocol developed by Cisco that can encapsulate a wide variety of network layer protocols inside virtual point-to-point connections. To protect network data by setting up circuits using IPSec tunneling, in which all data being sent between the two endpoints is encrypted, as with the virtual private network VPN connection. Encapsulating Security Payload, or ESP, provides data integrity, encryption, authentication, and anti-replay. The Internet Control Message Protocol, or ICMP, is a crucial component of the Internet Protocol Suite used for network diagnostic, error reporting, and operational queries. Unicast addressing is one host sends directly to another host, one-to-one. Broadcast addressing is one host sends information to all nodes at once, one-to-all, similar to a PA system. Multicast addressing is one host sends to many hosts simultaneously. One protocol that uses multicasting is Internet Group Management Protocol, or IGMP. Anycast has the host sends to a single IP address in multiple locations, and the network will route to the nearest or most optimum host. Thank you for watching this video. The next video will be TCP/IP Part 6, IP version 4 addressing. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.